From the device in your hand to the car on the road, batteries are the unsung heroes of our modern world. We rely on them constantly, but what exactly happens inside that little cylindrical shell? Let's find out in this video. Most people think of a battery as a storage tank for electricity, like a bucket for water. But that's not quite right. A battery doesn't store electricity, it stores chemical energy. It is like a tiny, portable chemical factory designed to convert chemical energy into electrical energy on demand. Every battery, from the smallest button cell to the largest car battery, relies on three fundamental ingredients. Number 1, the anode. This is the battery's negative terminal, often made of metals like zinc or lithium. The chemical reactions at the anode release electrons. This creates a buildup of electrons, making the anode negative. We can think of the anode as the electron source. Number 2, the cathode. This is the battery's positive terminal, typically made of a compound like manganese dioxide. Here, chemical reactions use up electrons. So the cathode becomes electron-poor and positively charged. We can think of the cathode as the electron destination. And number 3, the electrolyte. This is a chemical paste or liquid that separates the anode and cathode. Crucially, it blocks electrons from crossing directly, but it allows ions, charged atoms, to pass through. So, how do these three work together to create electricity? It all comes down to a fundamental chemical process called a redox reaction, a shorthand for reduction oxidation. Here's the simplified breakdown of the process. At the anode, the material readily gives up electrons. This process, called oxidation, produces positively charged ions, and the released electrons accumulate at the anode. These electrons are drawn toward the cathode, which is deficient in electrons, but the electrolyte is in the way. It's an electron roadblock. So when we connect a wire and complete the circuit, the electrons get a way to move from the anode to the cathode. So the electrons leave the anode, move through the external wire, through your device lighting a bulb, powering a phone, and then finally reach the cathode. This flow of electrons is what we call electricity. When the electrons arrive at the cathode, it accepts them through certain chemical reactions. We call this reduction. Meanwhile, those positive ions created at the anode travel through the electrolyte to the cathode, balancing the charges and keeping the whole reaction flowing. It's this incredible dance of electrons and ions that empowers our portable world and continues to drive innovation in everything from sustainable energy to space exploration.